Good evening, friends. How are you all? So, repeatedly, I am showing this TSS because if you know a TSS in depth, then the PSI, the power supply installation, is almost will be under your what can I say? Adequate knowledge. But you have to study it thoroughly. First, how the current is flowing to the OHE. Second, the protection system, the instrument transformers, the protection transformer, and other protection lighting arrestor. Then some other protection for transformer protection. The power supply protection is mainly taken through this instrument transformer CTPT, and lightning is arrested for protecting from lightning. But the transformer protection and also for earthfall we are using earthfall relay EFR, restricted earthfall relay. Then only for transformer protection we are using so many relays. So many relays. I discussed it already, but again I like to repeat it. Then the function of CTPT. What is CT? Why? What is PT? Why it is used in power circuit? That is also required because CTPT is converting this huge power into controlling power operation. It is reducing it for control operation with 110 volt DC delaying system. So for this, so CTPT you must know clearly, and you should have that knowledge also that in circuit break condition only you can make or break the isolator switches. In circuit break condition, that means when the current is not flowing through the circuit, at that time only you can operate the isolator. This is the repetition again because it is opening in air, but for the circuit breaker it is in vacuum or some SFC's gas, some are old systems in oil, because it is breaking the current or making the current, huge amount of heat is generated, and if you don't extinguish it immediately, then a danger of fire accident. So relays are opening this circuit breaker. Circuit breaker can be closed or opened in nil current to normal load current, even the faulty current. Fault current also it can be closed or opened, but it will open immediately through the relay operation. And this interrupter, which is used in feeding side to feed OHE, this can also be closed or opened from no load to full load even in faulty condition, but it cannot open automatically except in SP neutral section. It cannot open automatically. It can be operated electrically, but not through the relay. You can operate it electrically and manually, but it cannot open with the help of relay automatically. So if you close it during faulty condition, then your circuit breaker will trip the circuit immediately. Trip the circuit immediately and protecting our OHE. So difference, try to understand this difference. Difference between CB and interrupter, you can understand. CB is associated with relays. This relays is helping to open it automatically during fault or any unusual occurrence. So it has the ability to open it during faulty condition or when a an unusual occurrence will occur, it can open automatically. And also for the transformer protection, some relays are there like pressure relief device, oil temperature awareness. These are all mechanical relays associated with electrical relays also for transformer protection and due to protect the power transformer because it is huge costly and may cause for fire accident if you don't protect it. So for protecting the power transformer, when transformer protection delay will occur, it will open both the CV both side. One is double pole circuit breaker, another is single pole isolator. Feeding side is not feeding transformer. Outgoing side is a CV, it is single pole, but for incoming it is double pole. Both the CV will trip to protect the transformer. It is for transformer protection, but for our OHE fault in our overhead system, any fault it will trip the feeder circuit breaker. And during fault isolation, we are closing the interrupter during fault condition also to check if the fault is permanent or not. At that time, during faulty condition, when you close the interrupter, the feeder CP will trip immediately because interrupter cannot open automatically. So feeder CP will trip. If feeder CP will not trip, there is a backup protection. The transformer 25 kV CP will trip. And the same way, lastly, the transformer double pole CB will trip. So this is the sequence. This is the sequence. And for HV side, that means incoming side, we are using an ammeter, then one overcurrent relay IDMT to permit the overload. Our traction transformer can bear 200% overload. That means if it is 10 MVA, it can deliver 20 MVA, but only for 5 minutes. So this is permitted by this IDMT delay, this overload. But if there is a huge fault, mainly in the HV side, then instantaneous relay will act. Overcurrent instantaneous relay will act. And if any earth leakage due to insulation failure or earth fault in HV side, the restricted earth fault relay 1 will trip the both the circuit breaker across the transformer to protect the transformer because earth fault near transformer is dangerous. So it will open both the circuit breaker across the power transformer. In the same way, in the 25 kV side, the output side of the transformer, here is the series single pole type. Isolator is also single pole type. And relay is used, ammeter and OCR IDMT and restricted earth fault relay. But no, generally, the IDMT relay is avoided in the transformer side. But the provision is there in the relay because numerical relay numerical delay both in primary and secondary is of same type, but the IDMT is not used generally. Then our feeder side, in feeder side we have potential transformer and current transformer, PT and CT, for protection and metering, for protection and metering of the feeder side. Feeder side kind how much CT will indicate, and voltage how much PT will indicate. With the metering also it is protecting. In feeder side we are using overcurrent relay, it will be sensed by CT, then delta I relay, CTPT both will sense, then distance protection relay, both CTPT coil will be used, and then long phase coupling relay, there is also the CTPT will be used, and under voltage over voltage is generally avoided. It is used in capacitor bank, for capacitor bank under voltage over voltage system we are using. And this is the protection of the feeder side. So this is the system, you try to understand clearly and able to calculate the delay setting. Relay setting is another technique. The calculating method you should know how to calculate it. Not a great thing, not a bigger thing. Simply you have to calculate the voltage, current, and the setting system, constant and everything. This is something conversion from higher to lower system. That means CT, if CT is current taking current 100 ampere, it will be converted to relay 5 ampere. So you should know this stepping down of current, and but stepping down of current means step up of voltage, but it is connected in series CT. So across the CT voltage is very minimum, because his volt ampere is only, you say, 100 volt ampere. Then if your current is 10 ampere, 100 ampere, then your current will be how much? 5 ampere in the secondary, and your voltage will be how much? If it is 100 volt ampere and your current is 100 ampere, then voltage is only 1 volt. No? Your 100 volt ampere current is 100 ampere, so across the primary the voltage is only 1 volt. Because it is connected in series, the voltage drop in it is very minimum. But at a time, if you think the voltage of the secondary output current is 5 ampere, but as it is 100 volt ampere, so voltage will be 20 volt. 20 volt. It is all permissible for panel board working. This voltage current, why you are using CTPT? Because we have to work manually with human. Man will operate all these things, operate the panel board, so he should be in safe condition. It should be in safe condition. So we have used these instrument transformers, the CTPT, to protect our operator. Otherwise, this huge power you cannot operate. So we are using control circuit for the panel board. It is 110 volt DC volt. Okay, today up to this, because the video will be more longer. Thank you. Later I will tell